Hello again. After that brief introduction in V model, that at each and every gate there are going to be simulations. Let's see the first important simulation or first important in-loop testing, as it is called. The first in-loop testing is model in-loop testing for ADAS. Okay, let's briefly touch upon what exactly this model in-loop testing is. Model in loop testing. Now, before I explain you, let me give you a brief prologue about model in testing. In a highly competitive and time sensitive market like automotive, it is crucial to test new solutions before they are realized. All right, I think everybody who has experience knows that before the final solution is offered to the end customer, extensive testing has to be done. Now, model in loop makes this possible by creating mathematical models that represent the solution in real part and part virtual manner. Testing automotive embedded software and software at model in loop level is the first step in the process of V&V. Now let's see what is this model in loop. As you can see in the V model here, in the system designing, you can see model in loop. So model in loop testing involves integrating simulation models to verify and validate ADAS functionalities. It is crucial for assessing performance before physical test. Model in loop testing is a simulation technique that uses a model to test a system or subsystem. Or in other words, we are checking the accuracy of the model. And how is this model built? This model is built using tools like MATLAB or Simulink. And majorly MATLAB. Most of the OEMs, when they are developing models through model-based design or model-based system engineering, they are using MATLAB because they find MATLAB a very efficient tool. In simple words, model in loop is a way to verify the accuracy and correctness of the model generated. A model in loop system enables the engineering to build a realistic model. Let me tell you, this is not accurate. A realistic model, because all certain simulation is simulation. Simulation cannot be real world testing. But the efficacy of simulation lies in the fact that the results are as close to the accurate results as possible. Okay, the more closer the simulation results are giving you, the more efficient the testing is, or the more efficient the simulation is. So to build the ideal model in simulation with his own realistic build and afterwards test it and improve it continuously. A model in loop, clearly understand this sentence. A model in loop system, test system enables the engineer to build a realistic model and replace an ideal model in the simulation with his own realistic build and afterwards test it and improve it continuously. And one of the most important parts of successful autonomous driving or ADAS application is the software and control logic for vehicles, vehicle control and safety functions. So in this particular application, model in loop is very extensively used. Safety is always a top priority, so modeling as many situations as possible and test the software as detailed as possible is a crucial step in the development for any system. So to ensure that model is as accurate possible, we have to test the model in various situations, in various scenarios, in various perspectives. Only then we can come to the conclusion that model is correct. So how are you going to test the model? Okay, model in sorry, there's slight repetition here. To complete a realistic model, following is required: vehicle dynamics software to simulate the dynamics for the vehicle as well as sensor locations and driving behavior. Exclusively when we are checking for ADAS, exclusively when we are checking for any automotive application, a vehicle dynamics software to simulate the dynamics for the vehicle as well as sensor locations. So not only how the vehicle will work in the real life. For example, which it may include acceleration or deceleration or suspension or oscillation over the suspension. All these things as well as sensor location and driving behavior. Scenario simulation software to simulate the environment, traffic, obstacles, and other environmental influences. Okay, this is also a kind of tool. And one more important thing which is required is a high performance processing power. One of the reasons why model in loop test has been adopted so widely in automotive industry. Now, why is it so easily adoptable? Is because of the availability. This word is important. Availability of simulation tools and environments such as Simulink. And designing the plant model controller model, and complete test harness have to be simplified to a large extent. So, with the help of Simulink or MATLAB, we can we can design the complete plant model. What is plant? Nothing but vehicle model, controller model, and the complete test harness, wiring harness. All these things can be modeled, and the much needed traceability is also provided by these tools, and hence they are also recommended by standards such as ISO 26262 and ISO 21434 secure 21434 cyber security mod, this one also. And automotive OEMs and tier ones are always trying to beat the clock when it comes to building innovative automotive solutions. After all, these solutions become the USPs in the industry as competitive as automotive. In an industry as competitive as automotive, uh, developing as fast as possible is the main unique selling point. And model-based design approach, along with the modeling loop testing, play a crucial role in enhancing the efficiency of automotive development and validation. Okay, understand the importance of modeling. Let me explain this model in a very layman language. You develop a model using some modeling software like MATLAB, and then you put it through some simulative tests. And based on the results, which you already know what you get when an idealistic model is there, based on the results, you confirm that the model which you generated is correct or not. It is as simple as that. What are the main key concepts? Methodology details. Model in loop involves building a model for virtual testing, enabling developers to detect issues early and optimize design. Okay, let me explain in a way where all of you can understand. Instead of automotive, let me take an example of a model building. A model building or a model of a construction, and then you put it in a earthquake simulator. Earthquake simulator. So if a model is able to stay without breaking in an earthquake simulator, then the model is correct. Okay, it does not confirm that design is correct. At least it confirms that model is correct. So first of all, the purpose of the model in testing is to ensure that the model which we have generated is correct. And what are the main fundamental principles? Understanding the basics of model in loop testing includes simulation, model fidelity. This is very important. You are checking the fidelity of the model, and test environments essential for ADAS. Now, what are the various advantages of MIL? First advantage is you are detecting the errors early. MIL testing allows for early detection of design flaws, reducing the need for costly revisions later in the development. Second is cost efficiency. By simulating tests, organizations can save on physical testing expenses and minimize the resources needed for full vehicle prototypes. Well, this is actually any simulation has the same advantage, cost efficiency. Instead of developing the entire prototype, you are simulating a model, and then you are seeing the efficacy of the model. Third is improved safety. Because we are able to check the correctness of the model, you can be assured of the end safety. Testing in a controlled environment enhances safety by allowing for safe simulation of hazardous scenarios. What are all the various testing phases? The phases in the modeling testing represent a structured approach to ensure through evaluation and validation of ADAS systems. What are the first phase? Model development. Next is test planning. Third is execution analysis, and fourth is validation. Okay, let's explain each phase. What is the model development? Creating simulation models, define requirements, and develop computational models. So these are the key activities when it comes to model development. Second is test planning. So what are the various test procedures? What are the various test criteria? What are all the various test protocols? All these things will be decided in this second step. And third is execution analysis, which means running the actual tests and analyzing the results. Conduct simulations, gather data, validate outcomes. Okay, and last is validation. Confirm the model accuracy and reliability, whether the model is accurate or reliable or not. This is the step where we confirm. And how do we confirm? we compare results with benchmarks. We compare results with benchmarks. Okay, that's how we confirm the efficacy of the model. But again, model in loop, as efficient as it comes with its own challenges. What is the biggest challenge? The model in loop testing in ADAS encounters challenges like model inaccuracies, complexity of scenarios. As you can understand, in ADAS, scenarios are highly complex. Anybody who drives a car knows how many parameters are involved in actual driving in a road, whether it's a pedestrian or a bicyclist or a motorist, or even in a country like India, even buffaloes and donkeys cross the road. So all these complexities have to be taken care. So developing a model to encompass all these various scenarios is a big challenge in itself, and integration issues with the real world data and computational constraints. So integrating all these issues with the real world data, and there are of course computational constraints, because it requires a lot of computational power. Developing a model and then testing requires a lot of computational power. Of course, nowadays that particular challenge is overcome because computers are very powerful nowadays. They have huge RAMs, they have huge GB RAMs, which are comfortably able to run this computation. But nevertheless, it has its own challenge. Now, what are the future trends in the model in loop? First of all, we, as everybody knows, in every area AI is entering. AI is penetrating in every area. The incorporation of AI in model in loop testing is expected to enhance predictive capabilities, and making simulations more reliable and accurate. Okay, so actually there are some OEMs who are asking the prototype developers to ensure the prototype is so efficient, or rather simulation model is so efficient, they can just bypass the prototype. Instead of making a prototype, they can, based on simulation results itself, they want to go into bulk production. So naturally that requires highest level of accuracy. Okay, so, and this level of accuracy can be achieved with AI as per many people. So future trend is AI integration. And second important trend is increased automation. Automation of testing processes will streamline workflows and enhance efficiency, resulting in faster time to market. So faster the automation, faster the time to market. Now this is a very linear equation or a very linear statement. Now advanced simulation tools. Emerging simulation techniques will provide more realistic environments. Now again, there's no need to repeat this, but please understand that more realistic a simulation is, better the accuracy. So the more realistic environment, it increases the accuracy of MIL testing outcomes. Okay, thank you.